Hi everyone, this lesson is for Algebra 2 Honors students. This is Chapter 6, new chapter for logarithms. This is day 1. We are starting on section 6.4. So getting started, this is a review for exponents. So we've got negative 3 to the 4th power, which is going to be a positive number because it's an even number here. You're squaring twice a negative number. So basically just negative 3 times negative 3 times negative 3 times negative 3. And negative 3 times negative 3, 9 times 9, and this is just 81. Don't put an equal sign. There's no equal sign. Don't add one if there's not one there. It's not an equation, it's an expression. This problem here, however, is saying take the opposite of whatever 3 to the 4th power is. So we know 3 to the 4th power is 81. So the opposite of that is negative 81. For this problem here, what you are meant to do here, and yeah, I know that's not supposed to be there, but what you're meant to be here is this 5 is going to be distributed to the exponents of both of the values inside the parentheses. So that's going to be multiplied through. So that 5 times 1, and then 5 times 1 again. So this is realistically 3 to the 5th power times 7 to the 5th power, and then that's it. You're trying to, yes, we're going to use a calculator, but for the most part, we want to minimize the calculator so that you're not actually depending on that for part of this chapter. For this problem here, I just want to remind you that back when you learned multiplying exponents, so like you were like 2 to the 4th power times 2 to the 3rd power. The rule is basically you keep the base and you add the exponents, 4 plus 3, which is 7. And that's if you're multiplying. So if you're dividing, you're keeping the base, which is still 2. They have to be like bases. And then you subtract the exponents. So it's going to be 25 minus 5. So that's going to be 2 to the 20th power. For this problem here, and then you can, yes, you can do that. I don't know, what is that? 2 to the 20th power. Not necessary to solve that. That's like 1 million. It's over 1 million. So no, don't write that. We're done. For this problem here, I would simplify what's in the parentheses first, right? So you're going to have 3 to the 5th power, which is the answer. However, just a note, you could have done it like this. You know that 12, and you distribute, again, that 5 to both, the 1 here and here. So that's 12 to the 5th power over 4 to the 5th power. And realistically, I could have taken this 12, right, and split that up to be 3 times 4. And if I had done that, I would have gotten, no equal sign, that's an arrow, 3 times 4, right, to the 5th power over 4 to the 5th power. And when I distribute that 5, I would have 3 to the 5th power times 4 to the 5th power all over 4 to the 5th power. And then the 4 to the 5th powers cancel anyways. I'm left with 3 to the 5th power like I would have done in the beginning if I had reduced it. The problem here on the right, this problem is saying, this is scientific notation. You've probably seen that before. You know you have to split these, right? So you can only subtract exponents that have common bases, like the 4s. So I could split these up right here and then this right here. So 7 halves, right? That's going to be 3 and 1/2, or 3.5, and then times. You guys are used to the times, or put the dot there. That's way better. So 3.5 times this 4, and that'll be 4, and then that's just 2001 minus 1997, and that's just 4. So this is going to be 3.5 times 4 to the 4th power, and then you just leave it. That's your answer. Okay. So our learning targets today are dealing with exponentiation. For rational exponents, we are going to be evaluating powers, hopefully without a calculator. We are going to be simplifying expressions involving rational exponents, and increasing and decreasing exponential functions. So I like this. This is because this is an exponential thing. It's like if you know Lady Gaga, rah, rah. All right, you can sing it. This is cool. Anyway, so exponentiation these are like the rules of exponentiation. So negative exponents. The rules are x to the negative n power, that's 1 over n, okay? Likewise, though, just note, if you had a variable on the denominator, I don't know, or even a number like 2 to the negative third power, negative any power, when I bring this back up to the numerator, right, that's now going to be 2 to the third power. That's a positive value. Every time you change a level, so that's 1, x to the n, when I bring that down to the bottom level, to the denominator, that negative sign changes to be positive anytime you change the level, okay? 0 exponent, anything to the 0 power is 1. X to 0 power is 1. 1,340,000, whatever, to the 0 power is 1. Reciprocal exponents. This is just saying, just rewriting this basically. X to the 1 over n is the same thing as saying the nth root of x to the 1 power, right? You know, when do we see that? We see that like when we're saying x to the, I don't know, 5, 6 power. I can rewrite that as the 6th root of x to the 5th power. Okay, so it's just a way to rewrite something. Fractional exponents, x to the, like what I just did, actually, that's what that is. X to the a over b is what I just did here. Okay, so that was actually a better example of that. X to the 3/4, again, this is realistically the 4th root of x, and that's to the 3rd power. Okay. So vocabulary, here's our vocabulary. These are like very, very important to know. N, this right here is my root. That's the nth root. So it could be a square root, which by the way, we don't usually put a 2 in there. It's just known to be, that's a square root. There's a 2 hidden in there that we don't see. We could say the 4th power, right? So that would be the 4th root index. That's what my root index means. X is my radicand, and then this is the radical sign, okay? But I think for me the biggest word here to pass on to you is the radicand, because that's the value underneath the root. That's that value. Also, it's this base, right? Because if I rewrote it as x to the 1 over n power, right? If that was the 1, x is my radicand. That's also another way of saying that's my base, isn't it? So here's our exponential expressions. Your job is to simplify these without a calculator as best you can. So 64, think about that, is you could write that as 8 squared, right? So we want to try to take the values that they give us and reduce them down, okay? I also could also say that 64 is 2 to the 6th power, okay? So I'm going to do 2 different things here, all right? The first way I would do this, because everybody's going to do these differently, whichever way works best for you. That's 8 squared. That's this value here. But that's still to the 3/2 power, right? That 2 to the 6th power is still to the 3/2 power. So for this part here, the 2's are going to cancel and make 1. I'm left with 8 to the 3rd power. And now I can use my calculator. So 8 to the 3rd power is 512. So this no equal sign is a 512, 512. For this problem here, right, 2 divides into 6, because that's over 1, 3 times. 3 times 3 is 9, so this is 2 to the 9th power. 2 to the 9th power, shocking, is also 512, okay? For this problem here, so I mean, like, yeah, there's 2 different ways you could do this. Which way appeals to you more? That's what we're looking for. For this problem, this is 1 over 25. Like, just like the other problem on the previous slide. Rewriting this, this is actually 1 over 5 squared, okay? That's 25, 5 squared. It's still to the negative 3/2 power, which means that negative 3/2 has to, again, be distributed to both of the values, both of those exponents. So we have 1 to the negative 3/2 power over 5 squared to the negative 3/2 power. 1 to anything is just 1. Okay, so that's not really doing anything for us. That's 1. This, though, is going to significantly change. We've got 2's are going to cancel, okay? And now I have 1 over 5 to the negative 3rd power. See this 5 to the negative 3? I'm going to move it to the top. And now it is 5 to the 3rd power. And I know I was going somewhere with this, and then I went down instead of over. So this is now 5 to the 3rd power, and 5 to the 3rd power is 5 times 5, which is 25. 25 times 5 is 125. So this answer would be 125. Yeah. Next problem. 27 to the 2/3 power. That's 27. I can rewrite 27. And, you can do this. Oops. You can do this where you're sort of working on the side, right? You're saying, well, 27 breaks down to 9 times 3. 9 breaks down to 3 times 3. That's 3 3. So 27 can be rewritten as 3 to the 3rd power and then to the 2/3 power. The 3's are going to cancel and make 1. 1 times 2 is 2. So now I have 3 squared. 3 squared is 9. Box that up. 136. I don't know. 130. I'm just going to start off dividing that by 2. Maybe 4. 2. 2 is good. So I know that this breaks down to 2 times 68. I'm going to keep dividing that by 2. I get 34. 34 divided by 2 is 17, right? So this one is not the favorite. So 34 divided by 2 is 17, and I can't break that down. So this is what's happening here. This is one of those parenthesis ones. So we've got 2 squared, and I'm looking at the denominator. That's what I'm looking at, because I'm like, okay, what can go into that? Realistically, this isn't a nice problem. 2 to the 3rd power times 17 to the 1 power, and this is all to the 3/4 power is basically what we have. This isn't really going anywhere, except for I have to distribute that 3/4. So we have 2 to the 3 times 3, that's 9/4, nothing canceled, times 17 to the 3/4 power. So this right here actually doesn't look any better than what I started with. If I said 136 to the 136 to the 3 divided by 4 power, that's just going to give me a decimal, and that's not what we're after. So this is really the best way to write it, but if I had to rewrite it, that's how I would rewrite it. Okay, so for this problem here, so these are negative exponents. I know that it's a little bit big, but it's a negative exponents, like up there. So what happens with that is you want to go right to doing this. I mean, it depends how you feel, what you feel most comfortable with. We know that 81 breaks down to 3 to the 4th power. Done. So if I move this negative 3/4 down to the denominator, in the beginning, I have 81 to the positive 3/4. It became positive. And then I would take this 81 and I would replace it with 3 to the 4th, because 81 is actually 3 to the 4th power. And so by doing that, I get 3 to the 4th times 3/4. The 4's are going to cancel and make 1. I'm left with 1 over 3 to the 3rd, which is 3 times 3 is 9 times 3 is 27. And then that would be my answer. This is by no means the only way to do this. And that's the whole point. All of these problems can be done absolutely in a different order. 81, I could have just left it here and said, well, 81 is 3 to the 4th power to the negative 3/4. 4's are going to cancel. I'm left with 3 to the negative 3rd power, and then that becomes, again, down 1 over 27. For this problem here, nothing cancels here. So that negative 3/2 does distribute to both 4 and 9. What you're looking, though, for this problem is when you do distribute that, you're going to actually get 4 to the negative 3/2 divided by 9 to the negative 3/2. And right off the bat, nothing's happening. So it's something that you just have to get used to. You just automatically need to start reducing values. So see that 4? We need to break that down right in the beginning. So 4 is actually 2 squared. And then that 2 squared is to the, and this is over 1, yes, but we don't usually write that, negative 3/2 power. And then this 9 is actually, I'm not going to write 9 because I know 9 breaks down, right? 9 breaks down to 3 times 3, which is 3 squared to the, and it's still up, negative 3/2 power. So now what's happening is these 2's are going to cancel. On the bottom, I get 3 to the negative 3rd power. On the top, these 2's cancel, and I get 2 to the negative third power. So what I'm looking at right here is this, 2 to the negative third power over 3 to the negative third power. And this is going to move on because those negative powers, when I flip them and change the base from denominator to numerator or numerator to denominator, that changes that sign, that negative. So now on the denominator, I have 2 to the third power. On the numerator, I have 3 to the positive third power, which then just actually reduces, right, to 3 to the third, which is 27 over 8. 2 times 2, and you're done. Okay, and that's how you do that. For this problem, right from the beginning, you need to understand something. This is a negative value. It's not a square root. It's not imaginary. It is a cube root. This is telling me that my answer, when I'm all said and done, it is negative. Okay, because this is a cube root, which is a negative times negative times a negative. Now, before I do anything within my parentheses, I'm actually going to reduce. Always try to reduce what you can. So this 125 is going to be 5 to the third power over 8, which is 2 to the third power. And both of these are to the 2/3 power. So that's going to be times 2/3. You have to distribute that 2/3 here. Times 2 over 3. So 3's are going to cancel. 3's are going to cancel. I get the opposite of 5 squared over 2 squared. And that's going to be the opposite of 25 over 4. And that's how you do that problem. For this problem here, slightly different. You need to distribute these numbers outside here. So there's nothing outside here other than a 1, that's done. But this 3 needs to be distributed like this. All right? So that would be 5 to the third power times x squared times 3. Those are times, okay? It's not adding because that I don't have another exponent. It's only adding when you see another exponent attached to that 3. What we're doing realistically right now is we're taking x squared, right, and going x squared times x squared times x squared. Sorry, I have something in my throat. Okay, so this is going to be 3 times 2, which is 6. We have y to the 21 times 4 times y to the 8. So now, if you notice, my bases are the same. So I can say y to the 21 plus 8, which is to the 29th power. X to the 6 stays there. That's not going anywhere. 5 to the third, which is what? 125. So 125 times 4 is just 500. And that's all we can do, I believe, with this problem. We just box that up. Okay. Now, this one actually is saying use a calculator. That it is saying use a calculator. And the way you would use your calculator is they just want you to know how you can rewrite it. 121 to the, this is a 1 here that you don't see, right? 1 over 6 power. So you're going to say 85.766121 to the, and then usually you're going to use parentheses when you do the to the 1 divided by 6 power, and I get 2.1. Well, that's cool. Okay, and then I'm done. But on the TI Inspires, for sure, I'm not sure about the 84s, but the TI Inspires, it actually does this, where it has a box here. So when you type that in, you put the 6 here, you type in your number, enter, it's done. It's amazing calculator. Okay, simplify the following expression. So this one's, it's slightly tricky, a little bit tricky, because this is saying, what do you do first? Should I distribute the 6 first? That's option A. Or option B is, should I reduce first? Yes, you should always reduce first, definitely. So we are going to reduce first. So that means that I'm not going to touch the 6 yet. So I'm going to do this. I'm going to go, okay, 5 divides into 10 twice, 2's here. 12, 3. So this is actually p to the 12 minus 3, right? Because they're subtracting. Keep the base, subtract the exponents. 12 minus 3 is 9. So we have p to the 9th power on top. Then we have 9 to the 7th over 9, or n to the 7th. So we have n to the 7th minus 5. 7 minus 5 is 2. So then we have n squared. And guess what? Now I don't even have a denominator. I'm just going to get rid of that because that's not there anymore. And then all of this here is now to the 6th power. So we have 2 to the 6th. We have p to the multiply, because that was 1 times 6. 9 times 6, 54. N to the 2 times 6, 12. And then we're done. Now, keep in mind, if I had actually distributed that 6 first instead of reducing, my answer would look like this: p to the 72, n to the 42. Right? All of this would be over something else, like 5 to the 6th, p to the 18th, n to the 30th, 6 times 5. And then I would just reduce. Okay, then I would have to reduce out of all these numbers. And definitely an option for you to do and reduce, but why? Okay, this right here, again, try to simplify if you can, if you think it would make sense. Notice that only the top part here is cubed. All right, so dealing with that first, that's a big deal. That's going to be 6 to the 3rd power, x to the 2/7 times 3, which makes 6 over 7, y to the negative 12, z to the 0 is 1, that's gone. So now that's over all this stuff, 9x squared, y to the 5th, and z to the negative 8. Now, a lot of times, when you rewrite these, it was really hard for me not to write z to the 8th up here. Because of the negative value here, that's going to move to the top. And actually, I'm just going to do that now that I did. Likewise, this y to the negative 12 is going to drop down. Okay, so let's rewrite this. 6. So this is your option. The reason why I'm writing it out like this is because one of these 6's, this is 2 times 3. 3 divides into 9 3 times. This 6 is 2 times 3. That 3 divides into that remaining 3. And for my numbers, I have 2 times 2, which is 4 times 6, which is 24. So that's kind of tricky for sure. This z to the negative 8 went to the top, right? So that became z to the 8th on top. This y to the 12th went down to the bottom. And then I also had a y to the 5th down here. See that? And then I'm going to combine those at some point and say that's going to be y to the 17th power. Now for my x's, though they're just not the same. And realistically, you can keep the base and then subtract your exponent. 6/7 minus 2. Okay, so I'm just going to simplify this a little bit. I've got 24. I'm going to deal with the x in just a minute. Z to the 8th. And this is all over y to the 17th power. All right, so for the x, for dealing with this right here, you need a common denominator, which is not 1. So we're going to multiply this by 7 over 7. 6 minus 14. So 6 minus 14 is negative 8 over 7. So you have negative 8 over 7, which what that does is this. No equal signs. It gives me 24z to the 8th power on the numerator. And on the denominator, this brings us down to x to the positive 8/7, y to the 17th. And we're done. Because what we had here was this negative 8/7. When you're writing your answer, we don't want to see any negatives in our answer. Unless they say, the directions state, we don't want to see any denominators, and so you would then move everything up to the top. So it just depends on what the actual directions say. For this problem here, I like this problem. This is saying, look, see this negative 5? That's coming up to the top. So that's saying 7x to the positive 5 minus this negative 1, x to the negative 1, come to the top, 4x. Simplifying this, realistically, the only thing you could do is do this, and then you're done. You can even leave it like this, and that would be fine. Though for this problem, this one is a little bit trickier because you do have to distribute this negative 1/6. Then your choice is this. Do you want to distribute the negative value in the beginning and have everything over 1 or not? You know, that's what you have to decide. I'm actually just going to simplify as best I can. I'm going to take this 64, and I know that's 2 to the 6th power, times x squared. And then this negative 1/6 is going to be distributed. So this is times negative 1/6, and this is also times negative 1/6. So just dealing with this left side right here, I have these 6 cancels. I have 2 canceling into 6 3 times. So I have 2 to the negative 1, and then I have x to the negative 1/3. That's what I have so far. Times, and so then let's deal with this 32. 32 is actually 2 to the 5th power, and I see this negative 2/5. That's going to be multiplied, so that's times negative 2/5, and then times x to the 5th to the negative 2/5. So my 5s are going to cancel here and here. I'm left with 2 to the negative 2 times x to the negative 2. So for this problem now, we can just move everything to the denominator, or we can keep the base and add the exponents. I mean, like if I did that with these 2's, keep the base 2, add the exponents, negative 1 plus negative 2 is 2 to the negative 3. So what that means is instead of saying 2 to the negative 3, which is on the numerator, I'm going to take that 2 to the negative 3 and put it to the denominator, but make it positive. So my 2's are gone. And then now I'm just left dealing with the x to the negative 1/3 and negative 1/2. So again, you have x to the negative 1/3 plus negative 2. We got to get a common denominator, which is 3. So I'm going to multiply by 3 over 3, and I get negative 6/3. So I got negative 1 and negative 6, which makes negative 7/3. And so instead of writing it up here as x to the negative 7/3, like the 2, right? I'm not going to do that, and I'm going to rewrite it on the denominator as x to the positive 7/3, and this is just over 1. Because you definitely cannot leave nothing on the top, on the numerator. And then just finishing this is 8x to the 7/3. And if you're kind of wondering, you know, what is that? What does that even look like? It looks like this. It looks like 1 over x times the cube root of x to the 7th power. That's what it looks like. And realistically, now that I think about it, this is a great opportunity to simplify, because how many x's can I take out, right? X to the 7th is 1, 2, 3, 4, 5, 6, 7, right? 3 x's come out, 1 x is out. 3 x's come out, 1 x is out. So this is actually 1 over 8x squared times the square root of the cube root of x. And yeah, that cube root doesn't look good to be down there. So you would, another step could be that you would just get rid of that root on the denominator, and then you can multiply it by itself. But I already had the numerator up there, so we're going to move on from there for right now. So what we are doing next, so getting started on your homework, you have three pages that are pretty darn small. The 19 through 43 odd is just very simple problems, and I definitely try not to use your calculator because, just like how I was doing that, okay? That's pretty important to note, that you need to be able to do these quickly on your own without a calculator, other than the, higher numbers that you're multiplying. So thanks for watching. Good luck on your homework, and I'll see you in class.